Hello, myself Dr. Anita Chaudhary. In today's session, we will discuss about the logic gates. What it means in a computer circuit, the circuits always work on some logic like 0, 1. So how the calculations are performed, which will be discussed using the logic gates. So these are the logic gates which we will discuss in this session: AND gate, OR gate, NOT gate, XOR gate, NAND gate and NOR gate. Okay, so logic gates means a logic is a basic entity of any of the digital circuits, and logic gates are fundamental component, we can say, in a digital circuit system, because every circuit is created using the logic gates. We learned some seven main types of logic gates which are used for logical operations. Okay, logical operations which can be AND, OR, NOT, okay, and everything, bitwise operations, all these operations, even addition subtractions are also performed using the logic gates. Okay, and these logic gates are created using the diode, transistors, resistors and capacitors. So an electronic circuit is mainly created using the diodes, transistor, resistor and capacitors. Okay, so most of the logic gates have two input and one output unit. If we look around the AND gate, OR gate, then these gates have two input and one output. Okay, and when we talk about the binary number system, then it carries the bit 0 and 1. 0 means what? 0 means it indicates 0 voltage. Okay, so there is a no current in the circuit, and 1 represent the high voltage, which we can treat any of the voltage level, like here we have mentioned plus 5 volts. Okay, so 0 volt represent the 0 bit representation, and if there is a voltage in a circuit, then we call it as a 1, binary bit 1. Okay, now the types of logic gates. So a logic gates mainly have three different categories. One is the basic logic gates. Okay, there is a question that can be asked in competitive exams, like which are the basic logic gates. So remember, students, logic, there are three different basic logic gates: and, or, not. Okay, these are the basic logic gates. And sometimes the examiner asks about the universal logic gates, which are NOR gate and NAND gate. Every circuit is designed or derived using the NOR gate and NAND gate. These are called the universal logic gates. Remember this. This is one of the important uh, concept or question in a logic gates. Okay, so universal logic gates are NOR gate and NAND gate, whereas the basic logic gates are AND gate, OR gate and NOT gate. Now remaining two gates, which are XOR gate and XNOR gate. These two gates are called derived logic gates. So when we talk about the derived logic gates, then we represent it using the XOR gate and XNOR gate. Okay, they are represented using the XOR and XNOR. Okay, the formula we will discuss later. Like now if we have 0 and 1 bit, because computer is understand only 0 and 1, on, off, true, false. Now how we represent it? Okay, so 1 is represent the on situation, or we can say high voltage, the circuit is open, the right, and okay, yes and true. These are the state. If these are the states, then the circuit is treated as 1. And if the circuit or the bit representation is 0, then we called it as an off mode, low voltage, closed circuit, wrong, or no, or false. So they are opposite to each other. One is high voltage or binary representation is 1, whereas 0 is there is low voltage and circuit is closed. So these are called that's how the circuit is represent, or the 1 and 0 is represented in the circuit. Now AND gate. AND means this, this and this both. The situation should be I should be 1 in both the situation. Then only the true will be there. Otherwise, in every other situation, they are represented. The output is false. Okay. So AND is represented using the x is equal to a dot b. Now what is here a and b? Now a is representing the a and b are the input bits which can be 0 0 0 1 1 0 and 1 1. Now AND means the in if if both the inputs are true, then the output is only true, otherwise the output will be false. Okay, so next uh, a binary arrangement with two switches in the series like this one. If the circuit is open, that means 0 0, then the output is 0. Now if we want to activate the circuit and we say the bulb is gonna on, it is only possible when both the switches are on and the circuit is complete. So if the both the situations are uh, 1 1, then the circuit is closed and the output will be on. Okay, now OR gate. OR gate means if two input values are both 0, then only the output will be 0, otherwise the output is 1. So if so the expression is represent using the plus symbol. Plus means if any input is active, then the output is active. If both the inputs are deactivated, then only the output is deactivated. So x is equal to a plus b, and a here a and b are the inputs and x is the output. Now if the input is 0 0, then the output is 0. If the input is 0 1, that means there is a one input is active, then the output is active. Same if a is activated and b is deactivated, then only then again the output is activated, and if both the input a and b are activated, then the output is activated. So in a OR gate, if both the input are 0, then only the output is 0, otherwise in all the situations, in the remaining situations, the output is 1. Okay, now the circuit diagram of the OR. So we can say this is the circuit diagram. If both the circuits are open, then the output will be 0. The bulb will not be on. And if any one of the circuit is closed, so the current or the circuit will be closed, so the bulb will on, and we can say this is an active circuit. Now next one is the NOT gate. NOT gate means invert. We just complement, and that NOT gate is basically used in complement. Okay, one's complement, two's complement. Okay, so NOT gate is means invert. We just invert the input. Now this is the interesting because it takes only one input. Now what it do it just invert the input. Like if the input is A, it invert it. And how it represent X A bar. Okay, this one. So the if the input is active, then the output is deactivated. If the input is activated, then output is deactivated. Okay, so this is the truth table of the AND gate. Now next is the XOR gate. XOR gate is called the exclusive OR gate. Okay, now in exclusive OR gate, it is represented using this one, A XOR symbol, B. XOR symbol is represented using the plus and complete signal. Okay, and it is represented using the OR gate. This is the symbol of the OR gate, and we complement it. Okay, the truth table is here. If both the inputs are same, then the output is 0. So this is the interesting concept. If both the input are the same, then the output is 0. If the inputs are different, then the output is 1. Okay, so I'll show how this is constructed. That means X is equal to, how you create it, A B complement plus A complement B. Okay, now we look at here. So in the first situation, A is 0 and B is 0. Now this situation, we just inverted A 0 1. So this one is 0, and if we the input bit for first situation, the input is 0 and the B is also 0 and its complement is 1. The dot operation is here. Okay, plus A is 0, then its complement is 1, dot B is 0. So A and B is equal, A and B means 0 dot 1 is 0 plus 1 dot 0 means 0. So the output is 0. Whereas in the second situation, how we got it? Again we put A is 0, B bar is 1, 1's complement is 0. Now again A bar 0, 0, whose complement is 1. So we put here 1 dot B is 1. Okay, now 0, 0, 0 plus 1. So the output is 1. So that's how the XOR operation is work. A B bar plus A bar B. Now next is this is the basic logic diagram of the XOR gate. Okay, and it is created using the AND gate, OR gate and NOT gate. Okay, so this is the OR gate, this is the AND gate, and this is the NOT gate. Okay, that's how it is created, and this one is the formula. Okay, A bar B plus A B bar. Okay, now come to the NAND gate. NAND gate is basically AND with NOT. Okay, so this is the AND gate with NOT. Okay, so first we calculate the AND and we complement the output, and that's how we got the NAND. Okay, so the input is 0 0. When the input is 0 0, the output of the AND gate is 0, and when we complement it, we got the 1. So basically it reverse the operations of the AND gate, because when we look at the AND gate, there is only in a one situation the output is activated, and that is the when both the input are activated, then only the output is activated in the AND. Whereas in the NAND gate, it reverses the output. So in a one situation output is deactivated, which is 1 1. Okay, so it's an NAND gate is very simple to understand. Okay, and this is the circuit diagram of the NAND gate and with NOT. Now NOR gate. NOR gate is basically produced the opposite results of the OR gate. Means, as the name suggests, what we have do, we first calculate the OR and then complement it using the NOT gate. Okay, so this is the OR gate, and after calculating the output, what we do on the output, we apply the NOT gate. So, and this is the basic equation. So a plus b and its complement. Okay, so in OR gate there is always one, except one 0, there is always 1 1. When both the circuits are down, then only the complete circuit is down. Whereas if in the case of the NOR gate, if both the circuit are down, then the complete circuit is active and the output is activated. So now this NOR gate circuit diagram. Okay, so this is the OR gate and this is the NOT gate. Now XNOR gate. So first what we have to do, uh, we just create the equation of this. The equation of this XOR gate is represented using this one. Okay, so the equation is a bar dot b plus a dot b bar, and it is represented using the inverse, sorry, a b, a XOR b and its complement. So it's an XOR gate. If you look here, it's basically XOR gate and it's a complement. Okay, so same as in a XOR gate, when both the inputs are same, at that time the output will be 0, whereas in the case of the XNOR gate, when both the inputs are same, the output will be reverse. And this is the basic circuit diagram of the XOR gate. This is the circuit diagram of what? XOR gate. Okay, this is the circuit diagram of XOR gate. What we have to do, we just add NOT gate in front of the output of the XOR, and that's how the XNOR gate is created. Okay, so here we have created the logic gate names and its symbols, and here the Boolean representation or the equation of these diagrams. Now the uses of the gate. So the gates are uses in every circuit diagram, in circuits and sensors, and that basically works like traffic light, smoke sensor, doorbell, UPS chips, mobiles or calculators. Everywhere these circuits are used, and the circuits are created and built using the logic diagrams to apply some calculations. So thank you. If you have any query, you can uh, uh, drop a message. Thank you.